Hello, everyone, and welcome to Exponents and Radicals Lesson 7. This is the last lesson of the first unit, which is awesome, and it is part 2 of the rational exponents lesson. So let's skip through the review. We can do that in class. I just want to get started with writing powers as radicals. So we did a little bit of this last lesson, but it'll be a quick review. Maybe I'll do every second one or something like that. So we know if we use our flower power rule, the top one is going to be the exponent of the top number in the fraction, and the bottom number will be the root. So we can rewrite this as the sixth root of x. Here we have negative y all to the power of 5 over 4. And you got to be careful here because that the base of this exponent is y. It's not negative y. If it was negative y, we would have brackets here, but we don't. So we won't. So this becomes, we keep the negative on the outside, and it becomes the fourth root of y to the power of 5. Just want to give you a heads up that if I had something like for fourth root of y over 5, it's the same as saying in brackets the fourth root of y all to the power of 5. That's the exact same thing mathematically. So whether you put the exponent as a whole or as the exponent of the entire thing or the exponent underneath the root sign, it's not going to matter. The next one, negative z all to the power of 5 over 3. So 3 is our root, so we are going to have the third root of negative z all to the power of 5, or just to the power of 5 underneath. And this is okay. Actually, we have to bring it underneath because it's part of the base. It's okay to take an odd root of a negative number. It's okay to take an odd root. You can take we'll just say cube root for this one. Cube root of negative. That's okay. And that works for any odd root as well. The next one is negative z all to the power of negative 5 over 3. So we're just going to flip this right away and say that it is 1 over negative z all to the power of positive 5 over 3. That's how you make that exponent positive, is you flip it, and then you can say that is 1 over the third root of negative z to the power of 5. And then in the next one, we have 5 multiplied by t to the power of 3 over 4. So that exponent only acts on the t. The t is the base. The 5 isn't part of anything. So we can write that out front and say 5 multiplied by the fourth root of t to the power of 3. And that's as far as we go. In the next one, you can see that it's the same question, but now we have those brackets. So 5t is the base. So now you can say, well, we're going to take the fourth root of 5t, and then that is still the base, so we have to keep it in brackets, all to the power of 3. Awesome. I said I was going to do every second one, and here I am doing them all. So hopefully we can get through this quick. Now we're going to bring in some of the exponent laws into the mix, but don't be scared. You totally got this. So we have x to the power of 3 over 2 multiplied by x. So you can think of that as x to the power of 1 or x to the power of 2 over 2. And now when we multiply our exponents, we are going to add them. So remember that when we multiply exponents with the same base, we add. So we have x times x, that's the same base. We are going to add those exponents. So we get x to the power of 5 over 2. So when you add exponents, the base stays the same, or the denominator stays the same, and you add the numerator. So 3 plus 2 is 5, and then we leave the denominator. Just hopefully we'll go over that in class, but I got to go over everything. And now we can rewrite that as the square root of x to the power of 5. Now we have y to the power of 1 over 3 divided by y to the power of 5 over 3. So when we have exponents with the same base, we subtract, and we're dividing them. When we're dividing exponents with the same base, we subtract the exponents. And when we subtract fractions, we need to have the same denominator, or common denominator. So we have y to the power of 1/3 divided by y to the power of 5/3. 1/3 subtract 5/3 gives us negative 4/3. So we can write that as y to the power of negative 4 over 3. And we know if we have a negative exponent, we can flip it. So we have 1 over y to the power of 4 over 3. And then we can rewrite that as 1 over the third root of y to the power of 4. Perfect. Let's go over one more. I don't want to go over too many. I feel like this video is going to last forever because we have some hard examples to do as well. It's on the next page. So we have a to the power of 1/2 all to the power of 2 over 3. So when you have exponents, an exponent to an exponent, you end up multiplying. And when you multiply fractions, you multiply the tops together and the bottoms together. So 1 times 2 in the top is 2, and 2 times 3 in the bottom is 6. And then you can reduce that fraction. So 2 over 6 becomes 1 over 3. And then you can say that that is the third, or the cube root of a. Cool. Let's move on to 2 more down here. So we have 4 multiplied by x to the power of 3 over 4 multiplied by 3 times x all to the power of negative 1/2. So we can multiply all this together. So we have to, when we multiply powers with the same base, we have to add the exponents. And in order to add these fractions, they need to have a common denominator. So we can say off to the side 3 over 4 plus, we can't do negative 1/2, but if we multiply top and bottom by 2, then you can say negative 2 over 4. And then 3/4 plus negative 2/4 gives us 1/4. So we're going to have x to the power of 1/4, and then we have 4 times 3, which gives us 12. So that becomes 12x to the power of 1 over 4, and then we can write that as the fourth root of x. Done. Now we are looking at exponents with the same base, and we're dividing, so we end up subtracting those exponents. So you can, if you want to deal left or solve it left to right, 5 over 25, 5 divided by 25 is the same as 1/5. And now we have x to the power of 3 over 5 divided by x to the power of negative 3 over 5. So we can subtract those exponents. So we're going to have x 3 over 5 minus negative 3 over 5. So they already have a common denominator, so we can leave that denominator. And then 3 subtract negative 3 is the same as saying 3 plus 3. So we have 6 over 5. So it's 1/5 multiplied by x to the power of 6 over 5. And then we can say that is the same as 1/5 multiplied by the fifth root of x to the power of 6. Dang. Okay, let's go on to the next one. So these examples are getting more and more complicated, but as long as you follow the same rules, you will be totally okay. So this is what I was talking about earlier. All of these are equal to each other. Something good to remember. And you can use this rule to, now you can write radicals into powers. So before we were taking powers and we were converting them to radicals, we're going to go the opposite way. We're going to take a radical and we're going to write it as an exponent. So in this case, we have the third root, or the cube root of a to the power of 5. So we can write that as a to the power of 5 over 3. Remember, this is the root and this is the flower, or that's the power and that's the root. And then in this case, again, we have an a. It's the a to the power of 2 root 5, so a to the power of 2 over 5. Trying to scroll here. Here we go. Now we have square root of a to the power of 9, so you can rewrite that as a to the power of 9 over 2, because there is a 2 there. And then 1 over a to the power of 7, which can be written as 1 over a to the power of 7 over 2, or a to the negative 7 over 2, if you want. I think I'd accept both of these. All right, so now let's get into some trickier ones here. Write as a power and evaluate. So we have the square root of the square root of 1296, or 1296. The first thing we can do is take that inside and say that is like saying the square root of 1296 all to the power of 1/2. And then we can convert this square root sign right here. So we have 1296 to the power of 1/2 all to the power of 1/2. And when we multiply those together, we get 1296 to the power of 1 over 4. And you can evaluate that. Do you remember putting exponents into your calculator? You have to use that little hat symbol. But if you're putting in a fraction exponent, make sure you use brackets like that, so that it's to the power of 1 over 4, not just to the power of 1, and then divide the answer by 4. And if you evaluate that, you get 6. I'm not going to do b. B's a little bit weird. The square root of 169 is 13, so we should just be able to write 1 over 13. They've got like 4 extra steps to get there, but it just makes the most sense to just evaluate that one. Okay, we have the cube root of the square root of 64. So we can, if you want to do an intermediate step, deal with the 64 to the power of 1/2. And then you can say 64 to the power of 1/2 all to the power of 1/3. And then 1/2 times 1/3 is 1/6. And the sixth root of 64 is equal to 2. Cool. Now we are getting into variables and coefficients and numbers. So don't panic. You can totally do this. We have the cube root of 8x to the power of 5. So you can split this into the cube root of 8 multiplied by the cube root of x to the power of 5. And then we know the cube root of 8 is just 2. And then we can convert the cube root of x to the power of 5 into x to the power of 5 over 3. Now we have the fifth root of 32x cubed, so you can do the same thing where you split that 32, and that x cubed. And then the fifth root of 32 is just 2, and then we can convert that x into 3 over 5. And then we can do the same thing with the 900x, so I'm just going to skip that one. So here we have the cube root of x to the power of 5 multiplied by the cube root of x. So you can convert these into x to the power of 5 over 3 multiplied by x to the power of 1 over 3. And when you multiply exponents with the same base, oh no, what's happening? When you multiply exponents with the same base, you end up, adding them. So you add these, so 5 over 3 plus 1 over 3, they have a common denominator, which is great. So it should be 6 over 3, which you can reduce to x to the power of 2. And now we have 2 square root x multiplied by cube root of x. So you can say that this is 2 x to the power of 1/2. We convert that into a 1/2 multiplied by x to the 1/3. And when you multiply exponents with the same base, you can add them. 1/2 plus 1/3. You need to get a common denominator here. So it'll be 3 over 6 plus 2 over 6. Should be 5 over 6. So you can say 2 multiplied by x to the power of 5 over 6. Cool. A couple more examples. They get a little bit weird. I'll do 3 more. We have, actually, you know what? I'm not going to do A. We'll save that one for class. But let's do B because it's going to be weird. And we'll do C because it is also going to be weird. So we have the square root of the cube root of 64 multiplied by v to the power of 6. So we can rewrite what's under here if you'd like. So it's going to be the square root of 64 v6. Zoom in one more time. Might make my life a little bit easier. I don't have the dexterity to draw these little things here. 64 v6. The 6 looks identical. Silly. To the power of 1 over 3. And then we can convert this square root sign here into, we're going to do the nested brackets here, 64 v6, that's to the power of 1/3, all to the power of 1/2. So what you can do is, well, we have an exponent to an exponent, so we can multiply those. So we have 64 v to the power of 6, all to the power of 1 over 6. So you can also say that that's equal to 64 to the power of 1 over 6 multiplied by v to the power of 6 times 1 over 6 is 6 over 6, or reduces just to 1. 64 to the power of 1/6 is 2, and v to the power of 1 is just v. So you end up with 2v as your answer. The next one is pretty weird, but don't be freaked out. You can totally do this. So we have the fourth root of x to the power of 5 times y to the power of 3, all to the power of 3 over 2. So we can rewrite this as x to the power of 5, y to the power of 3, and we're going to convert this fourth root into exponent 1 over 4, all to the exponent 3 over 2. When you have exponent to an exponent, you can multiply them. So you end up getting x to the power of 5, y to the power of 3, all to the power of 1 times 3 is 3, 4 times 2 is 8. And then you can multiply that through. So I'm going to apply that exponent to my x to the power of 5 and to my y to the power of 3. So basically I have 5 times 3 over 8. So 5 multiplied by 3 over 8 is going to give me 15 over 8. So I can say x to the power of 15 over 8. And then I'm going to do the same thing with the y. 3 times 3 to the power of 8 is going to be 9 over 8. And I think that's as far as you can go with that. It's a weird one. Okay, cool. That was a long video. I apologize. I thought that was going to be a short one, but those examples took a long time. Thank you for watching. Have a great night.